so now let's talk about partial derivatives of functions of three variables. So remember, if I have a function of three variables, we represent it f of x, y, z equals w. So then you can find the partial derivative of w with respect to x, the partial derivative of w with respect to y, and the partial derivative of w with respect to z. So I have three variables, so I have three first partial derivatives, which you can also write with subscripts, f of f sub x, f sub y, and fz. And these are also defined in terms of limits, and they're similar to the limits that we had back for a function of two variables. They're just now for functions of three variables. So there's the one for x. The limit as delta y goes to 0. F of x, y plus delta y, z over delta z. But they really work the same way. You just have an extra variable. X, y, z over, this should have been delta z, and that one should have been delta y. Okay, so let's look at a problem where I need to find these partial derivatives for a function of three variables. So for part A, find fz for the function x times y plus y times z squared plus xz. So what would the partial derivative with respect to z be? Well, if I look at my first term, there's no z, so that's a constant, and the derivative of a constant is 0. So then over here, my second term, I have a y squared, I have a z squared, and y, that y is just constant, so it's going to be 2yz. And the same thing over here, I've got a z and my coefficient of x, so the derivative is just going to be x. All right, and then our second one we're going to look at, part B. I want to find fz for the function. It'll be z sine of xy squared plus 2z. So here, notice that you have a z out here and in this other term. So you're going to have to use the product rule to find fz. So copy the first one down. It's the derivative of the second one. So the partial derivative with respect to z of sine of xy squared 2z plus, now switch it, copy the second one down, times the partial derivative with respect to z of the first one, which was z. Well, the derivative of z is just 1, so this is just going to become sine of xy squared plus 2z. And then over here, I have to use the chain rule. The derivative of sine is cosine xy squared plus 2z, and then multiply by the derivative of the inside, and the derivative of the inside here, well, the first one is constant, so the derivative of that is 0, and then the second one, the derivative is going to be 2. So here is my answer for the partial derivative with respect to z.